We are now looking into Globe Technology Center via two cameras. On the left-hand side, we see Optima flexographic printing press. Nobody is by Optima because we will start this demo by S-mount, by the plate mounting procedure. David is our main printer for today. Hello, David. Hi, and let's start the demo. Our objective, our goal is to print expanded Gamut design and start with plate mounting, with automatic plate mounter, S-mount, which we recently developed. And we will start with mounting of one sleeve, one plate, then we take the sleeve into the printing press and we proceed with a job setting, and later on we print this demanding expanded Gamut design. So David is now going to mount one of the printing plates. S-mount needs to recognize the dot. So once S-mount sees the dot, that rectangle, blue rectangle in the middle flashes. See, now it's gone. And when we move with the dots, now it's there, okay? And we also see the dots a little bit with a red cross. So S-mount knows where the printing dots are, but we need to align them. And for that, we will use the round table, especially the round table, which handles also the old printing plates. And it's doing these microscopic movements in 2 or 3 steps to align the dots accordingly in the perfect position according to the recipe. And it's now finished. So positioning is finished, and we will proceed with mounting of the plate on the sleeve. One revelation, 360 degrees. If you take a closer look at the sleeve, we are using a twin lock self-adhesive sleeve for this particular job. We thought it's a good fit with expanded Gamut technology. Okay, the procedure is finished, so you see it's very fast. The benefit is also that it's very precise, always repeatable. So no more downtime on the press caused by improper mounting of the sleeve. That's the greatest benefit. Fully automated process. So theoretically, we could take the sleeve out and start printing, but we proceed with iris measurement. What it means, iris stands for Intelligent Register and Impression Setting. System which has 2 parts, one on the S-mount, on the plate mounter, and the other one in the printing press. And the main benefit for printer, for operator, is that in completely automatic process, on minimum of waste, we will set impression and register in perfect setting. So make ready time and waste is down to minimum. So what we are doing now, we are scanning the topography of the printing plate, which is the data which is used for impression setting on the press. And we are also locating the magnet position, which is built inside of the sleeve, which is used for for register setting. And the data, which is measured here, is stored in the RFID chip, the built-in chip inside of the sleeve. If you don't have RFID chips in your existing sleeve, don't worry, we may retrofit the magnet as well as the RFID chip into your existing sleeves without any troubles. From now on, we want to keep an eye on the sleeve as David will walk toward Optima printing press and insert the sleeve. So David is walking around the printing press. Maybe gallery view would be better. And here we are by the press. What we need to do, and you may proceed, David, it's fine. We need to scan the data first before we insert the sleeve. You see that the flash on the sensor is blinking. That means that the data has been transferring, it's finished, and David may insert the sleeve. And I just want you to notice that David did not lock the housing. It remains open. It will lock automatically as part of the advanced bounce control system. But let's take a look on the sleeves. This one is black. It means it's hard. And this is for a white color on printing deck number 8. And then it's five color job. So we use a blue intermediate hardness of twin lock sleeves. 5 that stands for CMYK plus orange. This is expanded gamut. We will not use violet. We will not use green. We will use only orange and CMYK. And as you heard, it's very demanding design because we are replacing 25 spot colors by 5 color CMYK plus orange print. All right, so this is all about expanded gamut. And for successful expanded gamut printing, you need 3 things. First, which is crucial, is mechanical stability, then thermal stability, and then ink stability. So take a look at this printing unit. It's one single block, cast iron, produced from one piece. It's very heavy and very rigid. The printing decks, David did not lock the housing because it's locked automatically. It's stronger than if it is locked by the construction is stronger. And the housing is extremely heavy. This is all about perfect registration. Expanded gamut means perfect registration and perfect impression. And for that, we have advanced bounce control. Part of the advanced bounce control, it's also drive setting procedure called job tuning. Okay, look at the printing material. It's rotating back and forth. We are analyzing dynamic properties of this particular job, of this particular sleeve and the plate. And accordingly, it sets a setting for drive. Result, even better registration. Okay, so advanced bounce control in combination with job tuning means perfect impression, perfect registration. Enough for that. Let's continue with job setting. We see zeros for all of the active printing decks, and we will proceed with IRIS, Intelligent Register and Impression Setting feature. This procedure is completely automatic, so David may take a rest. We will move forward with the web, okay? And during the setup procedure, we will later reverse back to initial position. So actually, the waste for setting is down to 0. We will get back to initial position, okay? One more movement forward with the web, and from now on we will reverse to initial position. And IRIS is starting with printing deck number 8 and printing deck number 4. Number 4 we are not using, but number 8 became white. That means that IRIS is doing the setting for register and impression based on the data which we measured on the plate mounter and which we transferred into the press by the RFID chip. Once it is finished right now, IRIS starts to set printing deck number 7 and printing deck number 3. So IRIS is always setting 2 printing decks at the same time. It's fairly quick, and then most importantly, it's automatic. So it's very precise, and human, the operator, may do other tasks. Okay, let's proceed with another expanded gamut features. We spoke about mechanical stability. Let's focus on thermal stability. We are now looking at the drying system, but I like to take a closer look at the central drum thermal stabilization. This is right here. You see that we are with 28 degrees of a central drum, and it's water cooled, and we maintain exactly 28 degrees. But not only that, we also measure the temperature of the frame for thermal stability. And accordingly, if this changes, we compensate the impression by means of the correction of impression on the printing decks. And not only thermal, but also in terms of speed. So printing deck impression is adjusted to the right temperature changes and to the right speed, which is being printed. And there is a third system which is unique on the market, and it's water-cooled printing decks, a system developed by SOMA, and we take a look at that a little bit later. So let's take a look back into the IRIS system. I see that IRIS is still setting, it's actually finishing the job because all of the IRIS are now white again, and we see the new data for register and impression. So intelligent register and impression setting is finished, and we may start printing. Before we do so, let's finish the discussion about the thermal stability. Let's take a look at that unique system from SOMA. We will have to walk back into the printing press, the system that is crucial for successful expanded gamut printing for thermal stability. On the left-hand side, you see a water, and you see the pipes going to each printing decks. So we are water cooling printing decks to retrieve the temperature out of the press. And on the right-hand side, you see perfectly isolated in-between deck drying. That's another component. Why do we do so? Well, let's go back. Why do we do so? Because we want to maintain a consistency through the whole print run. Thermal stability is a key part for keeping a registration and impression perfect during whole print, okay? So two systems developed by SOMA. Okay, David, fine, let's start printing. The camera, line screen camera, 100% inspection camera, as well as the web viewer camera are located on the left-hand side. The speed indicator is on the main control panel on the top. I hope that you are able to see it. Well, let's take a look at the camera first and then the speed. The speed is there, 330. Our target will be 400 meters per minute. And we see that we are printing this demanding expanded gamut design. Originally, this is a co-print of several jobs which contained 25 Pantone colors, and now it's printed all of them on one design, 400 meters per minute in perfect registration and impression. So let's move toward the central, toward the rewinder, and let's take the sample. And let's inspect the quality. So in terms of expanded gamut, successful expanded gamut, we spoke about mechanical, that means for perfect registration, that means advanced bounce control and job tuning. Then we spoke about thermal, which is central drum thermal stabilization, compensation for the frame temperature, and mainly printing deck thermal stabilization, which are water-cooled printing decks. And now the last part is ink, okay? Ink stability. And for that, we have two systems. One is the viscosity control, automatic viscosity control built in the inking system, as well as thermal stability control system. So we maintain the constant temperature, desired temperature, which we want to print. Very good. Several features on the Optima press to handle expanded gamut designs, just like this one. Again, it's all about registration, it's all about impression, and it's all about consistency through the whole print run. And look at this, several Pantone, 25 Pantone were used. If we look at the pet food, you see the white around, so you see that the registration is perfect, okay, equally distributed. Here are the partners, Marvaco in terms of prepress, Flint Group in terms of inks, packaging inks, XSYS in terms of the printing plates. We use Nyloflex. Okay, and Sandon for analogs and Tessa for twin lock self-adhesive. And of course, Optima, Soma Optima printing press in combination with S-mount automatic plate mount. So if you ask, what if Optima is ready for expanded Gamut? Yes, it is, and it is ready for short runs as well. So a great combination for efficiency and sustainability. David, it was perfect. Thank you very much. Jan, thank you. Jan behind the camera, thank you. Enjoy the day. Thank you. Let's get back to studio.